Hello, everyone. We're working through an introduction to statistical methods and data analysis by Ott and Longnecker. This is chapter 12, part 3. Okay, we're going to work on this at-home exercise. Suppose we are interested in examining the relationship between the selling price in thousands of dollars of a home and two independent variables. 22 homes were sampled. Y equals the selling price, X1 equals the number of rooms, and X2 equals the number of square feet. We can model the selling price as a linear combination of the number of rooms and the number of square feet by taking Y equal to beta 0 plus beta 1 X1 plus beta 2 X2 plus epsilon. We're going to fill in the missing values in the ANOVA table below. So we have, in this case, K equals 2. The number of parameters that we're estimating is equal to 3 because we will end up creating a model where Y hat equals beta 0 hat plus beta 1 hat X1 plus beta 2 hat X2. Okay, so we have our degrees of freedom equaling K, n minus K plus 1, and n minus 1. If 22 homes were sampled, we know that n right here is 22. Our K equals 2. Okay, to find the critical value, remember that we're going to put alpha equals 0.05 area in the upper tail. And in this case, our critical value is equal to 3.52. We also want to find our test statistic and our p-value. So first, we're going to find the mean squares due to regression. So mean squares due to regression, we're going to take our sum of squares due to regression and divide by our degrees of freedom due to regression. So our mean square due to regression in this case is 3408.39. All right, our mean squared error in this case is 213.1942. Our F test statistic is found by dividing the mean squared error by the mean square due to regression, and we get a value of 15.99. With associated p-value less than 0.001. It's almost equal to 0. It's right here given 0.12345. 0.00008, very, very small. Okay, so in this case, our p-value is definitely less than alpha. So let's set up our null and alternative hypothesis. HO beta 1 equals beta 2, which is equal to 0. HA, either beta 1 does not equal 0 or beta 2 does not equal 0, right? At least one of the beta j's does not equal 0. If HO is true, what is the distribution of our test statistic? Well, our F test statistic, all right, it follows an F distribution where degrees of freedom 1 is equal to 2 and degrees of freedom 2 is equal to 19. All right, we are drawing a picture of this distribution. It's a skewed right distribution. There's our critical value. Our test statistic was 15.99, right? Our test statistic was far beyond our critical value, right? This p-value here, the p-value is less than 0.001. And the alpha level, which is associated with critical value, right? Alpha was equal to 0.05. Okay, so since our p-value is less than 0.05, which equals alpha, we reject HO. All right, so in context of the problem, we say that using, let's say, the number of rooms in a house, number of rooms, and the square footage is predictive of the selling price of a home. So if someone said, what do you think my house is going to sell for? If they told you the number of rooms in their house and how big the house was, you would have some indication of the selling price going up or down using those variables, right? So you could think about the more rooms a house has, it's probably more expensive. The more square footage a house has, it's probably more expensive. These variables are telling you something about your outcome variable being the selling price of the home. All right, I hope you learned something today and that you can get these same values for your at-home exercise.